Hello everyone, am I audible? Yeah, good evening everyone. Yeah, actually today's class will be taken by me. So we'll be discussing about this object detection and object segmentation. So this class would be totally practical. We'll be actually uh, like saying how to implement if you have any custom data sets, so how to apply object detection and object segmentation. No voice, am I audible? Just can you please confirm all? Okay, so please check from your side. I think there is issue with your system. Uh, CNN, I think it would be start once. I mean, your next class itself. But today I'll be showing you this object detection and object segmentation practical implementation. Hope you got that. Yeah, if you can do it side by side, it's fine. Otherwise, you can go through the lecture later on. You can try. It's up to you. uh, yeah, because see, actually if you don't know anything, if you don't know about computer vision, it's fine. You will be understand. Suppose if you have I mean kinds of images, okay, and if you want to apply object detection, so what are the frameworks are available, okay. Because we'll be discussing about the Yolo v5 and this detect on true today. I think you have heard of. So that would be totally practical, okay. So if you have a Python knowledge, so I think you can get that. Is it fine with everyone? Uh, yeah, thank you. And okay, let me introduce myself. My name is Ahmed Bappy, and I'm working as a junior data scientist at One. Yeah, I can see your text, Srinivas. Yeah, so you can say we'll be just working on this practical part of object detection and segmentation. So I will be introduce this YOLO v5 and this your detect on true, okay, from Facebook side. Yeah, it is recording, so you can get the recording once this class is done. So it will take, I think, 24 hours to come. I mean, upgrade your dashboard, so you can watch it later. Nothing actually. If you understand Python, so you can get that. Okay. As of now, like theory is not required for understanding this object detection and segmentation. So just take it as a tool. Okay. Suppose if you want to apply object detection, so which framework you have and how to do that. Okay. What are the actually steps you have to perform? I will share the notebook and data each and everything. So and I will give you a task also. So once you have done this class, so I think you can uh, use your own custom data set. Okay. Actually, you can't see because only host and panelist can see. Okay, we have turned off the chat because if we turn on, then everybody will be chatting each other. So nobody will be concentrated on the class. So I think that is bad for everyone. Okay, so just instead of chatting each other, just focus on the class. So just try to understand. Okay, and we can discuss your doubt later on. So let me try. Okay, so let's start with our session. So I'm not watching chat yours. Okay, so if you have any queries, so we can discuss it later. And if you can, just try with me. Okay, otherwise just go through the lecture. Okay, so you can do it later. So I'm sharing the screen. Just confirm me once you are able to see. So is my screen is visible? Okay, thank you. Okay, I will share the link. Don't worry, just wait. Okay. So first of all, I'm sharing with you one GitHub repo. Just try to clone it. Uh, so this is the link. Just try to clone that repo, and once you have cloned, so you will be getting some file. So here is, you can say, another file called sign language generation IPynv file. Okay, it's a notebook file. So you can open it with your collab. Okay, so just try to upload it inside your like drive. So here, if I show you, so here actually inside your drive you have to upload it, and if you just double click it, and so it will open with your collab. Okay, collab notebook. If you have collab pro, then it's fine, because you will be getting more powerful GPU. But here I'm using the free collab, so it will do your job, because if you see the dataset size, so it's less actually. And here we'll be utilizing our custom dataset, okay, for this demonstration purpose. But later on, if you are collecting, I mean, thousands of data, so at that time you can go with this collab pro, so your training would be more fast. Bharat, what are you telling? Can you do it once, means? Okay, so here, if you see, after cloning the repo, so there is a file called sign language generation IPynb file. Okay, just copy that file, and upload it inside your Google Drive. Okay, just open your Google Drive and upload it. I think you know this basics operation. And open, and if you double click it, so it will open that notebook file with the collab. How to clone repo? Okay, so okay, let me show you. First of all, just create any folder. Okay, if you are creating any folder, now do you have git bash installed in your system? Do you have git bash? Okay, no. Okay, so I'm okay, what is it? Okay, are you familiar with the github? I think, yeah. Okay, so someone is telling he's not familiar with. Okay, it's fine. I'm telling you two options you can follow. So if you have a git bash, so if you just right click it, so you can see there is a git bash option. So if you can open your git bash here, and once you have opened your git bash, just go with this repository and click on this code. Okay, so here is a link, you can see https link. Just copy that link and open your that one, this your git bash, and you have to write just git space clone. Okay, git clone, and just paste the link here. Okay, and if I hit enter, so now you can see it is downloading this repository, okay, inside my local system. So it is taking time. Okay, so now if you click on the folder, so here you will be seeing the content like that. These are the content would be available. Okay, if I show you this yeah, so you can see these are the content would be available. Okay, and there is another option. So if you don't have any git bash, so what you can do, you can click on the code, and here you can see download zip. Okay, so if you just click on download zip, so it will download as zip file. Okay, so you can unzip it, and here you will be seeing a notebook file. So there is a drive. Okay, Google Drive, and if you just double click on that, so it will open up with this collab. Hope you got that idea. Okay, I'm sharing the link. So are you able to upload it? See, what you can do, just here is a copy. So if you just click here, it would be copied, and just open up your git bash and do right click. Okay, do right click, and you can see there is a option called paste. Okay, just paste it, but before that you have to write git clone. Okay, then paste it and hit enter. It will work. Yeah, no issue, you can go ahead. So do one thing, just download as a zip file. Okay, you don't have to clone. Download it as a zip file and unzip it, and copy that IPONV file, sign language generation, and upload it in your drive. Yeah, today we'll be discussing about object detection project and image segmentation. Okay, project. We'll be discussing about Yolo v5 and detect on true. Okay, no issue. So can you please confirm anybody done the cloning operation and uploaded this file to drive? Okay, done. Good. Are you able to open with the collab? I think you are familiar with the collab, na? Yeah. Yeah, I think so. If it is, in your syllabus, so it will be covered. Don't worry. Cloning. If you are getting cloning error, then do one thing. Just uh, download as a zip file. Okay, you don't have to clone. Just download as a zip file and unzip it and upload that file inside your drive. No. You don't have to upload all the file. You just have to upload that file. Sign language generation. Okay, IPONV file. That one. Yeah, it is enough. You don't have to worry about the theory as of now. It's just a practical implementation. You can say project implementation will be doing. Okay. So I think if you are familiar with the Python, so you can understand. Tarun, I think you got that. Okay, see, this is the file actually, sign language generation .ipynb file. I think you are familiar with Jupyter Notebook, na? So what is the Jupyter Notebook format? Yeah. So that notebook actually you have to upload inside your drive, and if you just double click it, so it will open up with the collab. Yeah. So if you open that, so you will get an interface like that. Okay, so can you please confirm from your side, should I show you the demo of the project? So what we are gonna actually build? Okay, I hope everybody has done. Yeah, okay. So now let me show you the demo of the project first of all. So see, actually, this is the demo. If you see, so if you just actually let me discuss about, first of all, it's a sign language actually detection. So I think actually there are lots of guy actually they cannot actually express their language. Okay, so they cannot talk actually. So for that, can we do? We can actually build kinds of system. Okay, kinds of, you can say, sign language. So there are lots of sign language over the internet you will be getting. Okay, how they actually express their language. So that kinds of actually system we are gonna implement by these projects. So if you just do like that, it will say hello. Okay, so just let me play the video. And if you do like that, so that means you are trying to say yes, and that means no. So if you do like that, uh, is trying to actually say please, and that means like you are trying to express I love you. Okay, so these are some sign language. Okay, I have collected the images. So I will be showing you like how did I collected the images, so you can also collect your image. Yeah, so I think you got the idea. Yeah, so isn't it fun? Like it's an interesting project, na, everyone? Yeah, so I will recommend just after that class, so try to implement, try to collect your own images and try to build that system and try to record that video and upload it in your LinkedIn profile. Okay, so that people can know you are already working on that, so they will be getting also interest. Okay, so I hope you got the idea what we are gonna actually implement through this session. So let me close that video. Okay, so before that, let's discuss about our images actually. So yeah, capture images. No, as of now, you don't have to move because I will show you like what I have done, and I will tell you like how you have to do also. Okay, as of now, it's fine. I'm just uploaded this data set with a zip file in my GitHub, and I have mentioned the URL. Okay, so you can directly use that URL to download this data set. Okay, as of now, it's fine. So now I will be showing you like how to collect the data. Okay, so it's not only sign language detection. So you can collect for different tasks also. But first of all, you need to define the task, like what are the object detection actually you are going to perform. So here actually we are going to detect the sign language. Okay, so that's why I was just doing like that. Okay, I was just doing like that. Okay, and I was just collecting the images, and I was doing the annotation. Okay, I will be showing you how to do annotation. But if you have a different task, suppose if you have a table, like all of you have the desk, right? Computer desk. So in on computer desks there would be lots of equipment, right? Your smartphone, then your mouse, your keyboard. Okay, so you can collect those images also, and you can do annotation. Okay, like this is the smartphone, this is the computer, this is the mouse. Okay, this is the pen, this is the pen box. That's how you can label that, and you can perform object detection on top of that. Okay, so at the end you will be implementing an object detection system. So if you just hold your camera on your table, so it will tell you everything, like which is your pen, which is your phone, which is your laptop, which is your camera. Okay, everything it will show you. So it's a kind of object detection. I think you are familiar with what is object detection. So if I search about object detection here, object detection. So object detection is nothing but there would be lots of objects actually. It is just try to identify those objects. So if I show you, so this is the images. Let me open. So here you can see there are some objects. Suppose this is the car. So it is detecting as car. This is dog, it is detecting as dog, and you can see the label also here. And there is a bicycle. Okay, it is also detecting the bicycle. So in an image, so what are the objects that are available? Your object detection model will try to identify those objects. Okay, so I think you have already seen this kinds of application, okay, over the internet. So we are going to learn that thing only here. So now I hope you got the idea what is object detection all about. Now let me show you like how to collect the images. Okay, so here we are going to perform this sign language detection system. So what are the actually level we have to keep it in our mind. Okay, so here let me show you the data first of all. So if you open up your data, so in the data folder here there is an option called collected images. Okay, I think it is available. Let me see. Okay, it is not available, it's fine. But if I show you, so see, there is a collected images option. So here if you run that script, okay, so this is the script actually, capture images.py. So if you just run that Python file, so it will open up your camera and it will start collecting your data. Okay, and it will automatically create that folder called collected images, and inside it will create hello. Okay, hello. And inside hello you can see this is the actually hello sign I'm trying to perform. Okay, I've just you can say hold my hand like that. So you can see this is the hello. So it will take 20 images first of all. So let me show you the script so you can I think get the idea. Let me open the script. I'm not going to run that script because already I'm running this Zoom. Okay, so if I run that, so it will slow up my laptop. Okay, so that's why. But later on you can try to run that script. So you just have to write Python capture underscore image.py, and if you hit enter, so it will run. But before that you need to install the Opencv library. Okay, so Opencv library you need to install, and if you run that Python script, so it will automatically open up your camera and it will start collecting the images. Okay, so here you can see I have mentioned 20 images as of now, number of images. So you can increase that size. Suppose you need 100 of images. So here you can mention 100. Okay, so it will click up 100 images in just one level. So let me show you. So here you can see I have collected 20 images. Now every folder if you open, so here you will be getting 20 number of images. But here if you mention 100, so during taking up your photo, automatically it will consider 100 images here instead of 20. Hope you got the idea. Py file is already there. So if you see here, so see capture image.py, it is already there. Yeah, so I hope you got that code. Like it's a basic just Python code. If you understand Python, so you will get the idea. And here I have taken a list. So I'm considering 6 actually label: hello, yes, no, thank you, then I love you, and please. Okay, so these 6 actually label I'm considering. If you have a more than 6 number of labels, so you can also mention here. So you have to just comma, and you can mention like crying. Okay, crying. Here you can mention like that. But here I will be using just 6 label as per my requirement. So if you want to know like what are the sign languages are available, so you can search here sign language, uh, sign languages. And if you open any kinds of website, if I open the images, so here you can see there are lots of sign language. Okay, you will be getting images. So from that you can learn actually what are the actually activity like express what are the actually language. Okay, so you can learn from here, and you can mention those level here. Okay, and you can collect the images. So then I'm performing a for loop. So this for loop, what it's doing, it is just trying to like getting the path, that means your collected images path, that means this folder path, and it is also trying to take the label name. That means if I show you here, so every folder contains the label name, right? So it is automatically creating this folder. So that's why I'm giving. And os.makeDrs means it is just trying to, sorry, it is just trying to make the folder, and it is capturing the images and after 2 seconds, it is saving that images here. Okay, so if I show you, it is just trying to save here. Okay, and it is starting taking another images. Okay, that's how I'm taking 20 number of images. And once your hello is done, it is trying to pick up this yes, and I'm also switching my pose to yes. Okay, and it is collecting the yes like that. So if I show you, so that was hello, and now this is yes. Okay, so now if I show you the yes pose, okay, so that means you are trying to express yes. Okay, so every loop, okay, it will be trying to collect 20 number of images, and once it is done, so it will give a message like that. So collecting images for, suppose if I'm collecting for hello, so it will show up collecting images for hello. Then once hello is done, it will tell like collecting images for yes. Okay, so as per your requirement, actually you need to switch those pose. Okay, hope you got the idea. Okay, Opencv is a library. Actually, you can Opencv means like it's a computer vision library. So here actually there are lots of hard cascade model you can directly use, and it is also for your computer vision application. Suppose if you want to open up your camera, and you can do a lots of things actually using Opencv. As of now, you don't have to understand the UID, but I can tell you what is UID here. So here you can see every image contains unique name, right, inside the folder. So UID is actually trying to generate this name. Okay, that means this ID it is generating, so that it cannot replace the existing image with the same images. Okay, so I'm generating different name, so that like it is getting a unique name. I think you got the idea. Yeah, you can use your mobile camera also, but the mobile will take time, because suppose you first of all you need to take up 20 images manually, then again you need to take up 20 images. That's how it will take time. But if you run that code, it will automatically taking up the images. So you have to just switch the pose. Suppose you have done like that. Suppose you're trying to say hello. Once 20 images is done, it will give you a message like you have to we are collecting for yes. Okay, so at that time you can switch the post like that. Okay, so you don't have to do anything. So once all the photo has been taken, so it will stop the camera. Yes, your computer webcam would be like taking the images. Yeah, hi Rishabh. Okay, so once you have collected all the images, so what you need to do, you need to actually make a, let me show you all images. You need to make a folder like that, and you will be pasting all the images here. Okay, like your hello, yes, no. Okay, every image you will be copying from the folder, and you will be keeping inside just one folder called all images. Okay, from there actually we will be doing the torrent split. So if I show you my final data, so that data actually I have shared with you. So if you open the test data, and if you open the images, so you can see these are my test images. And if I show my label, so these are actually label. Okay, I will show you how to generate this label. So it is the bounding box actually. So I will show you what is the reasons of interest. So just wait. So that's how actually you need to manage your folder structure. Okay, so this is the train images here. I have kept almost 120 images for training. And if I show you my testing, so I have kept here almost 30 images for testing. I have total 6 label, and each label contains 20 images. Okay, so you have the script already. You can open with your code editor, and here you can see. If you just go through the code, you can understand. I'm doing nothing here. I have taken all the 6 list. That means my level list, and as per requirement, I have just written here 20. That means it will just take 20 images. If you just increase that size, suppose you need 200 images. So here you just have to mention 200 images. So what it will do inside that folder, it will just taken up. So let me show you data, my collected images. Hello. So here you can see it has taken 20 images, but once you have changed that to 200, so it will take 200 images. Okay. And every for loop, okay, every iteration you have to change your pose. And for that, you can see the message collecting images for hello. First of all, it will print. Then again, it will say collecting images for yes. And then again, it will say collecting images for no. Okay. That's how it will be telling, and you need to change the pose actually. Hope you got the idea. Okay, so let me run that code. So I think you can, I don't know, my system will be hang or not. Let me try. So I'm closing my camera because it will open up my camera. So let's see. So if you want to run that code, so first of all, I think I have Opencv in my system. Okay. So I will open my terminal here. You can open up your Anaconda prompt. And I will activate my environment. So now if you just run that file, capture image.py. So for that, you need to write Python capture image. So if I now hit enter, so you can see it will open up my camera. So you can see it has opened my camera. And now actually you need to do the pose. And if you want to see like what is the image it is taking. So in my terminal, you can see it is collecting image for hello. Okay. So now you need to pose like hello. That means you are trying to say hello. Okay. I think it is lagging because my system is actually, it has been slow. So that's why you can feel like that. Okay. So once hello is done, so you will see the message, it will change to yes. Okay. Now you need to change the pose to yes. Okay. So see, I have changed my pose to yes. So it is collecting the images, and you need to actually, uh, shake your hand, like you can hold your left hand also. Okay. That's how we can collect from multiple sites. Now, if I close that one, and now if I show you the folder, so see, one folder has created called collected images. Inside collected images, I have taken hello. So if I open the hello, so see here, hello images there. Okay, this is the hello images. And if I open this yes, so here you can see yes has been also collected. Okay, that's how you have to wait till all the 6 level. Okay, what are the levels you have seen here inside the code script? You have to wait and you have to do pose like that for multiple sites. Suppose, let me open my camera. Suppose you are telling hello. Okay, once hello is done, so when you will see the message for yes, so you have to change the pose like yes. Okay, so you need to actually take the photo from multiple side. Suppose you have you can say hold on your right hand. Okay, once suppose you have hold on for 1 second, so again after 1 second you can hold on your left hand. Okay, that's how you will be taking from multiple hand, so that it would be like you can say more generalized images. I think you get the idea now how I've collected the data. uh, yeah, you can use both hand, but if you see nobody actually try to express the yes using both hand. Okay, suppose that if there is a blind person, so they will just do like that. So you need to understand he's trying to say yes actually. No, split, there is no code. You can manually take up, like if you need 100 images, so you can manually take up and you can create a folder called train and you can directly paste that. So I have already done that. You don't have to do. If you open up your data, so you can already see the trend split. Okay, yeah. CB package is not available. Just try to install pip install Python OpenCV Python. Sorry, if you do pip install OpenCV Python, so it will install. Okay, I will show you how to do the annotation. Yeah, you can take a better cam. Suppose you have attached with your web camera. Okay, it will automatically take up that camera. So for that, if I open the script, so let me open up the script. So here you can see video capture 0, right? 0 means like it will take up your web camera. Okay, and if you have multiple cameras, suppose you have attached 2 or 3 camera, at the time you can change the number 1, 2, 3 like that. But by default, if you just mention 3, sorry 0, so it will take up this web camera. And if you don't have attached with your web camera, so it will use your laptop camera only. So everybody please confirm, can you get the code, like can you get the strategy like what I did, like for collecting the images? Can you do that? Srinivas, what is your problem? Can you tell? Split, actually I have done manually. I told you now, suppose you have all the images, so let me show you. So collected images, so you have all the images, right? So now you have to copy all the images. Okay, you have to copy all the images and you need to create another folder. So here actually see, this is my collected images folder. After collecting, you will get, these are the folder and these are the label. Okay, so you have to enter in, I mean each folder, and you have to copy all the images, and you will be creating another file called uh, all images. So inside all images you will be pasting all the 122 images around. Okay, see 8 to 10, suppose here what I'm doing, I'm just trying to like take I'm just taking the number of images. So this is the for loop for this label. Okay, it is just trying to take this label. Suppose first of all it is trying to take hello, so it is the hello loop. Okay, inside hello loop I'm taking 20 images. So this is my number of images I have mentioned. Okay, it is taking 20 images. Once it is done, so it is again going to that loop, and it is taking yes. So inside yes I'm taking another 20 images. Okay, that's how I'm doing for all the levels. Hope you got that, Dhruv. So it is a basic actually OpenCV code. So if you just write it, so if you just press Q, okay, from your keyboard, if you press Q button, so it will automatically open up, close up your camera. So this is the default code from Opencv side you need to write. Yeah, see, you don't have to give any directory here. uh, I have given the collected images now, so it is just folder name. You can define any folder name as per your requirement. It's a custom code. You can run it from anywhere. So see, I have run it here only. So see, here I have run. So it has automatically created that folder, collected images, and inside collected images, it has created those folders, and it has taken the picture. See, yeah, you have to download the Opencv. For that, just write pip install python opencv python. Sorry. So see, if you want to install Opencv, so Opencv py. So this is the official py site. So this is the command actually, pip install Opencv python. So here's the command I have given. You can try. Yes, you can take the picture externally also, and you can upload it inside a folder. But here I have written a Python code. So by using that Python code, actually I'm trying to take the images. Yeah, I'll be discussing. So first of all, I hope you got the idea like how to collect the images. So there is a script called captureimages.py. If you run that script, okay, so it will open up your camera and it will ask for the pose. Okay, suppose I think you have seen. So if I open that, so it was telling collecting images for hello. So once you are seeing like it is telling collecting images for hello, so you need to pose like that, hello. Okay, so you need to pose like that, and once hello is done, then you need to change the pose. Okay, once hello is done, suppose it is now telling for the yes. Okay, so now you need to change the pose to yes, and once it will tell for no, so you have to pose like that, no. Okay, so all the labels I have given you. Okay, I think you know all the label. Otherwise I can give you the label. Okay, so you can see that, okay, what are the labels actually I have and how to pose. And if you do like that, that means you are trying to say please. Okay, that's how actually you will be collecting all the six labels. Okay, all the six labels images, and once it is done, you will be copying all the images and you will create a folder called all images, and you will be pasting those images inside that. Yeah, you can integrate with any software. Okay, suppose if you want to like build a system. Okay, suppose if I talk about my meeting camera. Okay, so you can also integrate that. Suppose someone is like cannot talk, so they can just pose and you can see like what is trying to actually express. Okay, so actually it's a later on phase, so you can build a product. But like how to build a product, like what is the technique actually behind this computer vision technique, like how to detect the actually your this kinds of pose. Okay, so you are just learning here. So I hope everybody got the idea like about the data. And don't worry, I have already provided the data. So if you just open up your data, so you have already ready data. So here let me show you final data you have. So inside final you have your training images. See, you have your training images. Don't consider the labels. What is label as of now? I will tell you what is label. And test images. Okay, you have test images, and there is a YAML file. Okay, I will show you what is YAML file here I have created. Because if you want to train it with the Yolo v5, at that time actually you need that file actually, data.yaml file. You don't have to give any path. See, if you run that code, it will automatically create the path for you. You don't have to mention anything. Okay. Suppose you have run that script and you will be getting that kinds of folder called collected images. Inside you have all the 6 labels. Suppose hello. Inside hello, you will be getting hello related images. And inside this that one, you will be getting all the images. And if you clicked on the snow, you'll be getting all the no images. Okay. So once you have all the images, what you will do, you have to copy all the images. Suppose from this hello folder, from this no, please, thanks, yes. Okay. All the image you have to copy, and you need to create another folder called all images. Okay. So inside all images, you need to paste. See here, I have all the images. Then once you have all the images, then I will be starting doing the annotation. Code is nothing. So see here, what I'm doing. First of all, I'm taking my root folder name. So this is my root folder. So let me show you. Yeah. So this is my root folder. So you can see collected images. So this is the collected images. This is my root folder. And inside this root folder, I have my label name. Okay. Hello, no, please, thanks, yes, everything. Okay. So see, these are my label name. Okay. As per the label name, I'm trying to define a for loop so that each iteration, it will switch to one by one. Suppose first of all, it will take hello and it will ask for hello pose. Okay. So at that time, you need to do the hello pose. And once 20 image has been taken, so it will like give another message. So see, this is the message actually. So collecting images for hello. Then once hello is done, then it will say collecting images for yes. Okay. So that's how actually you need to change those pose as per the message requirement. Then once your 6th label has been done, so now you can get all the labels here. Okay, all the labels here. And if you open that labels, so here you will be getting all the pictures. Okay, all the pictures you will be getting. So now once you have all the images, so what you need to do, you need to copy all the images from all the folder, and you need to create another folder called all images, and you will be pasting. It's a simple. I think you got that idea. No, Collab cannot access your camera, na. So it's in cloud, but your camera is in your local system. Okay. So now that's how actually you can collect your custom data. Otherwise, there are lots of data if you find from Kaggle also. So if you just do Kaggle, if you, I think you familiar with this Kaggle. So you will be automatically getting this label images. So you don't have to label it also. So here you can search any data set. Suppose you need sign language data. Okay, sign language recognition data. If you just search that, so here you will be getting a lots of images data. So you can directly download that and you can use that. But here my motto was I need to show you like how to collect your own data. Okay, because if you are collecting your own data, so you can train a best model. See, once you have this script file, where is my script file? Yeah, this is the script file. Just open up your this anaconda prompt here and just type python captured underscore image.py, and if you run that, so it will automatically open up your camera. Don't run it now, because now you are in Zoom meeting, so it will slow up your computer. So once this class is done, okay, you can refer the recording and you can collect those images. Okay, as of now I have provided you the data set, so just try to use that. Yes, and you will feel like, yeah, I have collected my data set. I haven't used anyone else data set. Okay, so you can share your data set with other also. Yeah, actually, this is the environment in my folder itself. Well, but you can use default conda create. You can say virtual environment command. It's fine. Okay. I think you were familiar with this basic concept, like how to create environment, how to activate the environment, how to install requirement.txt file. Okay, because you are learning the deep learning here. I think you are already familiar with this kinds of concept. I'm already assuming. Yeah, because people are asking so basic things. Okay, I didn't expect that. And this basic things you can learn from the internet. Okay, there are lots of YouTube video. So if you just go with 10 to 15 minutes, okay, so you can get this that only. No, don't execute this capture image underscore dot image file inside the collab, because collab cannot access your camera. You have to run it in local. Once your image is collected, once everything is ready, then we'll be shifting to the collab. As of now, we are working on our local itself. Okay, so I hope you got the idea like how I got this all images. So let me show you all image. Okay, so I think now you are familiar with how I got this all images. Okay, so now actually if you see, uh, let me show you. Let me delete that one. I don't need. So here you will be getting another folder called annotation tool. Yes, collected images would be automatically created. You don't have to do anything. You don't have to open the this script also. Okay, but if you want to open, you can change this parameter only, like how many images you want. As of now, I have considered 20 images, but for you, you might be considered 100 or 200 images. Okay, it's up to you. But for your task, you can take more number of images. Okay, once you are able to understand this lecture, okay, so you can collect your own images, like around 100 images, and you can train a model, and you can show me later on. Okay, you can mention me in LinkedIn, so that like I can get to know, okay, you are already have implemented these kinds of projects. Okay, yes, once every level is done, it will close automatically. Okay, you don't have to worry. No, again, you don't have to run. See, that's why you can see the two for loop now. I think you are familiar with the Python code. If I am explaining the code, so one for loop is considering your level, okay, and another for loop is considering your number of images. See, okay, I will share. Okay, I will share at the last of this class. Okay, as of now, just consider this lecture. Okay, once it is done, then I will share everything, so you can build it and you can mention me also once you have done. Okay, so now motion, see, you don't have to worry about the motion, because that's why we are using the framework now. Yolo v5 we are using, so Yolo v5 will take care of everything. So you just have to train your model, that's it. Once you have your model, like I think you have worked with the machine learning, right? So once you have trained your model, so you will save it with a pickle format. Okay, and once you have the pickle format, so you can do anything. You can create a web application, you can create you can say desktop application, anything you can create, right? So that's how in deep learning also, if you're creating any kinds of computer vision model, so once your model is ready, so you can do all sorts of things. Okay, so I will give you that script also, like how to run the video. You can implement that one. Actually, I have shown you the procedure. Okay, so you can download the images and you can train your model. But as of now, my motto was like I wanted to show you like your custom data, like if you are collecting the data, because at the Kaggle itself you won't be getting all the data set, right? So at the time you need to generate your data. So that's how actually you can collect the data. That's why data collection is more expensive task, right? It takes a lots of time. Model training is it's a, you can say, easy task, but collecting data is, it would be a hard task, and labeling the data. Okay, so I'm closing that script. I hope everybody got the idea. Yeah, for loop is the, suppose it is trying to, what is the use of for loop? Suppose here if I show you the data, so see, you can see six you can see label. One is hello, no, yes, thanks. Okay, every time it is picking up those labels and it is creating the folder. Inside folder, it is automatically taking 20 number of images and it is saving those images, and again it is taking another folder. It is saving all the images. That's how it is doing automatically. You don't have to worry anything. That's why I've written this Python script now. But otherwise, if I didn't write this script, so you need to manually collect those data set. You need to open up your camera and you need to like click up, click up, click up. That's why you need to collect the images. But as of now, we have done the automation. Yeah. Yeah. Because if you have the Python tool, so why you will be you can say doing manually, nah? So you can automate everything using Python as of now. Okay. So always think about like a smart task, like try to build something automate thing. Okay, so that you don't have to spend a lots of time, because we don't have that much of time. Okay, so that's why. So now I think you got the idea, like how to collect the data. And once you have data, so uh, you have to see actually copy all the images inside this all images folder. Now actually you need to start the annotation. Okay, so for the annotation, so I think there is a tool, I think you have seen annotation tool folder. So inside, yeah, there is a tool called label img. Have you got that? Yes. So now if you just double click on that, so now if you just double click on that, so it will open up this label img tool. So you don't have to install anything for that. See, now you'll be getting that kinds of interface. Are you able to get that? Anyone from your side, can you please confirm me? Are you able to get this UI? Okay. Okay. Same screen. Okay, thank you. Now what you need to do, here you can see there is an option called open directory. Okay, so you have to just click on open directory and you need to select actually where is your all images presented. So inside my data, I have all images. See, okay, I have all images. So I will just select that folder, and here I will be clicking select folder. Okay, so it is telling data, all images, select folder. Okay, so now if you do like that, so it will open up all the images here. Yeah, yeah, label me you can use for segmentation task, because there we have a polygon, you can say annotator. Okay, but here you have this rectangular box annotator. Okay, so see, you don't have to annotate right now because I have already given you the annotation format. Okay, I just want to show like how to annotate the data. Okay, if you have just raw images, like how to annotate this data. Okay, that's it. So now see, if you just open up your directory, so you'll be getting like that. Now here actually you need to start the annotation. Okay, so for that, here actually you need to suppose, see, if you see the Pascal VOC here, so you need to switch it to the YOLO. Okay, so that's how actually you need, your screen would be look like. Suppose you can see Pascal VOC, just click on that and you can see the YOLO, because we will be using the YOLO format dataset. Okay, YOLO format label actually, because that it would be saved txt format, so that's why. But if you select this that one, that Pascal VOC, so it will be selecting as XML file, but we don't want that. But XML file, when it required, when we'll be using this TensorFlow object detection framework, at that time it is required. But if you are using this YOLO v5, at that time you need to switch to YOLO format. Yeah. YOLO v5 is actually it's an algorithm, okay, object detection algorithm. So a researcher had implemented, okay. So you can use that to detect object actually. So it's a different architecture actually. So what they have done, they have actually YOLO has a lots of version, YOLO v1, YOLO v2, YOLO v5, YOLO v4, like that. They have lots of version, but as of now YOLO v5 is the best, I mean, version, and it is implemented using Python. So that's why you can understand the code. But YOLO v3, that was implemented using, you can say, other language like C++, okay. But nobody of us actually can't understand the C++ code, right? So we are familiar with the Python, so that's why we will be using this YOLO v5 only. And it's an actually state of the art algorithm. Actually, you can see the latency and the detection speed, actually it's very optimistic, okay. If you feel like if you're running with the TensorFlow model, so at that time you will be feeling like it is lagging, okay, you're during the prediction time. But if you're using this YOLO, so at the time your prediction will be more smooth, okay. That is the thing here, because at the backend it is utilizing the SSD based, you can say, model architecture. So you'll be learning what is SSD, what is first RCNN, okay, everything they will be discussing about. But this is the practical actually class. We'll be just doing the implementation, but theory you'll be learning later on. So see here, actually you need to switch to the YOLO. So once you have the YOLO, now what you need to do, you need to select this create rectangle box, okay. So if you just click on that, so now actually you need to do the annotation, okay. So see, this is my actually interest of the objects. So here actually my computer is trying to figure out, I'm trying to say hello, okay. So you just always need to annotate those region of interest, okay, which you want to detect actually, okay. Suppose you want to detect the eyes, so at the time you need to like annotate the eyes, okay, like then nose, that's how you need to detect. But here what I will be detecting, I will be detecting this activity actually, a sign language activity. That's why I'll be you can say creating that kinds of bounding box here. And here actually you need to mention the level. Suppose that here I am trying to say hello, okay. So I'll be telling hello and okay, okay. Once it is done, so here actually here is the option, let me show you. If you click on view, and if you just click on auto save, okay, just click on auto save, so it will auto save your level, okay. You don't have to save it. So now you can go to your next images, and here you will be selecting another box and doing the annotation, okay. Again hello, okay. When it is done, then save it. So it will automatically save, and let me show you where it is saving actually. So if I open my data, so it will save inside that folder only. So see here actually you can see there is a hello.txt file. So here you can see all the, you can say, your bounding box, okay. That means this 4 bounding box you will be getting, this 4 point, okay. This is 1 point, this is 1 point, this is another point, this is another point, okay. These are the 4 point you can see here, okay. And it is defining a label here, that means 0, okay. And once I'm switching to another format, suppose that means I'm trying to say let me take another one, okay. That means I'm trying to say yes. So I'll be doing the annotation, and here I'll be mentioning yes, okay, okay. And now if I save it, and now if I show you that yes, what I have done, yeah. If you open the yes, now you can see this is another level called 1, okay. So that's how actually it is trying to save the information, because we'll be passing those level, okay. But that's how actually my model will understand, like my model will be training, like it will get the actually actual your feature, okay. This is the feature it will be considering, and it will be training the model. Yeah, you have to pass your annotation file also, and you have to pass your image file also. Then in the backend, it will map up everything. Yeah. Because now you have your raw image, so you cannot give the raw image to your model. Now, so first of all, for training, we need to show my model. Yeah, this is my actually level. Okay, that means I'm trying to say yes. Okay, and once I'm passing my levels, it will be learning on top of that. And once it will be learning, and it will you can say learning those parameters. At that time, we can pass our test images, so it will automatically predict. Yeah, that means I'm trying to say yes. Coordinate, see, this is the coordinate actually. Have you opened up your paint software? I mean, see, if you open up your paint software and if you just hover your mouse here, so at the bottom here you can see your x coordinate and y coordinate. See, so if I hover that here, so at the bottom right hand side you can see x equal to 228 and y equal to 231. Okay, so if I show you that, okay, so this is for yes. So yeah, so this is the actually your points. Okay, that's how you'll be getting all the points. But it is just actually scaled points, so that's how you cannot relate with that. Because this I think you have heard of this scaling operation in machine learning. So if we have a big number of value, we do scale operation, right? So here it is trying to apply this scaling operation, and it will saving the coordinate. Yes, because if we give a higher number of values, so at the time my training time would be like very high, right? So yeah, so what are the machine learning concept you have learned, so everything would be utilizing here. You're welcome. So now I hope you got the idea, like how I'm trying to do the annotation and what is those txt file all about, what are the information it is trying to save. I think you got that. Yeah, so if you open up your data folder and if you open up this label folder, here you can see all the txt file would be available. And if you open up your image folder, all the image would be available. And if you just relate them, so as per your images, okay, your label should be there. Okay, like not like that, like you have taken your training images but you have mentioned your test level there. Okay, that's how you don't have to mention. So suppose I have an image called 1.png. So what I will do, I will take 1.txt. Okay, that images I will be keeping in that specific folder. Okay, I will be taking 2.png. Which editor are you talking about, Dinesh? Okay, I already told you now. So here actually after collecting all the data, after collecting all the data, you need to copy all the images and you need to uh, create another folder called all images. Inside all images, you need to like save your all the images. Okay, and whenever you are opening your label img tool, at the time you need to open your directory. Okay, click on open your directory, open directory, and you need to select, okay, where actually you have all the images. So see, I have inside all my images, so I'll be selecting that folder and I will select. Okay, it will automatically open up all the images. See, at the right hand side file list, you can see all the images. Okay, and it will be make sure you are at the first position and you have done the annotation. Okay, if I click on the second images, so let me show you. So this is my first images I have done, so you can see it is already annotated. This is my second images, this is my third images I haven't done. So what I need to do, make sure you have selected Yolo and create rectangle box and do the annotation. And this is like hello, so you'll be selecting hello. Okay, okay, so once it is done, just click on the save. Okay, click on the save, so it would be saved, okay, inside that folder file. So here you can see it has saved with hello. Okay, hello.txt. And if you open this this name, okay, so see, this is the name and this is the name. Okay, these are same name. Okay, so corresponding that it will save those information here. And once you have all the annotation to annotation.txt file, so let me show you. So see, once you have all the annotation file, so what you need to do, you need to do the train test split like that. So you will be creating your final data folder, and inside train, okay, inside train images, so you'll be taking some number of images here and corresponding that images, okay, make sure this name and your txt file name are same. Okay, you need to keep it inside this label folder. Okay, that's how. Hope you got the idea. Yes, every image is presented inside your folder, I mean all images file, because I have already done the annotation, so I don't want to show you all the, because it will take time, because annotation takes time usually. So here I have done some of the annotation, but you need to do all the annotation. Okay, what are the images are available, you need to do the annotation. Suppose here I have suppose I have 100 images. Okay, so if you do the annotation of 100 images, so you'll be getting 200 items, okay, in that folder, and each image will contain their corresponding txt file. Okay, and you need to first of all just suppose I have 200, you can say, items here. What I will do, I will copy those images and with corresponding their txt file, and I will be separate them. Okay, and I will be creating train folder and test folder, and I will pasting inside that. Yes, annotation you need to do manually, because annotation you can't automate. Okay, because labeling you need to do manually anyhow. So that is the actually main task in, you can say, AI system. Okay, and that is the very expensive task, it takes time actually. Train test, see, if you have collected if you have done all the annotation, okay, so that's how actually you need to do all the annotation. You need to do again next, and you need to do again annotation, like this is means like hello. Okay, and you need to save. So once you have done all the images, you need to actually copy. Suppose here you have 100 images, so you have collected around 80 images for training, and with corresponding to their labels, and 20 images for testing. Okay, that's how you need to manually separate them. Yeah, also you can open up this train test I mean directory and do the annotation also, you can save like that, but that is the easy way. Okay, because from here actually you can select your train and test size actually as per your requirement. Yes, splitting you need to do manually, and even it's fine if you are not doing splitting, it's fine, you can directly use those data set for training, because testing we just need to see the performance of my model, right? As it is not like that, like you need to always give the train test split. Okay, it's not like that, but you can use this train dataset for validation also, it's fine, but it is recommended actually whenever you are trying to build a system, I mean training a model, just try to also mention some validation dataset for that. Okay, so I think so once you have done, so you will be creating train and test. Train, as of now, don't consider this label data.yaml. Suppose I have opened up my train. Inside train, see here all my images. Okay, here I have collected around 120 images, and as per this this image corresponds. Okay, so make sure you are copying those label.txt file. Okay, whichever contains this name actually. Okay, so see if I open my label txt, so this is the same name actually. These are the same file. Okay, inside my images, and here also. Okay, these are the same files. And if you open up this txt file, it will contain your bounding box. Okay, that means your coordinate points and with respect to their level, and these are separated by tab. No, annotation, actually there are no code. Annotation can be done only manually. You cannot automate. Okay, so I hope you got the idea, like how to do annotation. Yes, it's time consuming process. That's why I have shared with you the level. So that's why every people will tell, like data collection is the hardest task. Okay, in the deep learning or machine learning anywhere. Because once you have everything is ready, then you need to do the training. So it is very easy to train, but it is very hard to, I mean, prepare your data set. It's up to you, like you can take 30, 20. Okay, if you have large data sets, so you can take thousands. Okay, it's fine, it's up to you. But as of now, we have just taken around 200 images. Okay, 200 to, we can say, 160 images. So we have taken for training, you can say almost 120 for training, and around 30 to 40 for our testing. Okay, so hope you got the idea, like how to do annotation. I'm again showing you another time. Just see carefully. I've closed my level img. So first of all, you have to open your level img tool. The tool is already there. See, inside this annotation tool, you have level img tool. Okay, just double click on that, so it will automatically open up, and you will get that kinds of interface. Dhruv, I think you got that. Then just click here, open directory, and here you need to select actually where actually your images are present. So I have present in my all images. I'll be clicking and selecting, select the folder. Okay, and these images actually I have already annotated, so that's why it is showing. But if you just delete those txt file, let me show you. Data, all images. If you delete the txt file here, okay, so you won't be seeing that thing. Yes, any object detection, so you need that tool. Okay, but every object detection frameworks has different format, because we are using Yolo v5 now. So Yolo v5 only considered the Yolo format. But if you are using TensorFlow object detection, so at that time you need to pass as TF record format. So we have to save it as XML file here. So if you just switch to Yolo to Pascal VOC, so it will save as Pascal VOC format, that means XML format. And there is this script called XML to your TF record converter. So you'll be convert that your TF record, I mean your XML to TF record. Then you will be passing your TensorFlow model. Okay, that's how actually there are different tools. But as of now, YOLO is the ready to use actually framework. You don't have to set up so many of things. So that's why most of the people actually prefers this YOLO v5. TensorFlow supports TF record, .tf record. I think tomorrow we'll be discussing about the TensorFlow. Okay. As of now, just don't consider YOLO v3 and YOLO v5. Just consider we are learning YOLO v5, and every time you need to use YOLO v5, because YOLO v3 has been written in C++, and that thing actually As of now, nobody uses, okay, because these were old implementation. But now this recent implementation is YOLO v5, and this is the state of the art model as of now. We'll be using that only. Okay, so I hope you got the idea like how to do the data annotation. Okay. Okay, so now once you have done the annotation and once you have done the trend test split, so that would be your final data, and you have to copy all the labels. Okay, like what are the training images you will be taking? Okay, these are training images I have taken. Make sure corresponding that you need to pick up those labels. Okay, corresponding that, not randomly. Make sure you are selecting those actually, I mean, this name. Okay, you're following this name and you are copying those level file here, and that's how you need to take your test images also, like train image also. Okay, I have taken, and here you can see there is another file called data.yaml file. So if I open this data.yaml file, so it's an YAML actually format. That means Yarkub markup actually language. Okay, it calls YAML. So actually you need to write here you need to mention your training folder. So this is my training images here. Okay, so let me show you. So here inside my train I have images. Okay, so that path actually I'm defining here. And your validation, where is your validation? So your let me show you. Your validation means like your test images. So I'm defining my test slash the images. Okay, test slash images. And your number of classes you need to mention, like NC means your number of classes. So I have 6 classes. Okay, almost 6 classes I have. 1 2 3 4 5 6. So that's why I have mentioned 6 classes. But if you are have 7 to 10 classes, so you need to mention here. And you need to also pass as a list, okay, all of your classes name here, like hello, no, please, thanks, yes. Okay, everything you need to mention here. So that is the YAML file actually, data.yaml. Make sure you are giving that name only. You don't have to download a label img. I have already shared with you. If you see your annotation tool folder, so you will be already getting. You just double click on that, it will automatically open. YAML file actually we need because during training I won't be mentioning my directly my image, I mean path. Okay, what I will do, I will just give this YAML file to my model, and it will automatically pick up those path actually. Here we are mentioning those path, number of classes, and the name of the classes. So I think you got the idea like what is data.yaml file and what is the use of that. Because anytime you can change the path here, you can change the number of level here. Okay, yes, manually you have to do the splitting. That's why I've given you the data. Just consider that data set. Okay, and if you're doing the splitting operation, you can do manually or you can write a Python script for that. It's up to you. Okay, because everything it is not possible like to show in the class, because you know Python. If you know Python, you can automate everything. I have already shown you. Like image we used to take manually. Now I have a script. If I open that script, it will take automatically images for me, right? So that's how you can explore over the internet like how to do that trend split on image data. Okay, so you can write a script and you can give your path, so it will automatically create your trend folder and test folder, and it will automatically copy those images. Okay, so it's up to you, just create. Okay, otherwise we have less number of images, we can do it manually. No, there is no calculation of trend test split. It's totally up to you. Okay, suppose you have 100 images, just take 80 images for your training, keep 20 images for validation. That's it. So should I proceed, guys? Is it fine with everyone? Okay, thanks for the confirmation. I think tomorrow, if you have class, so I'm not sure. I think tomorrow you have class, huh? Okay, off. Okay, then we'll be discussing like next class. Okay, whenever it would be, we'll be discussing about this TensorFlow object detection one. And if time allows, today I'll be finishing the detection two also. Otherwise, like I'll be just discussing about this yellow. Okay, because once you have the understanding on one, you can understand the left one also. Okay, so this was our data.yaml file, and this is the final format actually, guys. If you see, uh, like final data, and inside your final data, your format would be like that. Okay, that thing actually you need to upload in your you can say drive, or you can keep it anywhere. We'll be reading that data and we'll be doing our job. Resources for OpenCV, actually I can say there are lots of YouTube videos. Okay, good videos you can see. You can pick like OpenCV CV in one video. You can take anyone, like 1 and 2 hours lecture. Okay, so you can go through that basics of the thing. Okay, we'll get the idea. Okay, I will share at the last of this class. Okay, as of now, just focus on that. OpenCV actually helps us actually for many tasks. Okay, so there are no end of OpenCV. Okay, because OpenCV every day they are upgrading the OpenCV. Even if you don't know deep learning, if you don't know computer vision, you can use OpenCV to build this kinds of system. Okay, it is like how much powerful. But here we are using OpenCV as a tool, like for some task. Like here we are using OpenCV for clicking the picture. Okay, for taking the picture actually. So OpenCV is taking the picture for us automatically. We don't have to click the button for that. Yeah. Okay, so see, TensorFlow is a framework. Okay, TensorFlow is a deep learning framework, and OpenCV is just a Python framework. OpenCV actually, it's a, how can I say, it's a hard cascade actually tool. Okay, uh, actually they are not using core deep learning here, but TensorFlow is a framework. Okay, machine learning or deep learning framework you can say, and you can actually build you can say machine learning algorithm, and you can say deep learning algorithm using TensorFlow. Okay, it is supports to your GPU. Okay, it works with the tensors, but OpenCV is just a tool, just a framework. You can import some of the method or attribute, and you can do your job, like opening camera, detecting face. Okay, so these are already implemented thing. But if you want to build it from scratch, so at that time you need to write in TensorFlow or PyTorch. Okay, this kinds of framework you need to use. Yes, because what is core deep learning actually? Now you're learning the core deep learning. Okay, but if you search in YouTube, sign language detection using OpenCV, there are lots of implementation, but these are not actually optimized. These are not actually robust, because they're using some hard cascade model. Okay, like some you can say hard coded model, but here we are creating our own model actually. Okay. Okay, so now let's discuss about our notebook. Okay, so what I have done, I have just given you this sign language data set. Okay, inside your that GitHub. Okay, you can get the data. So that thing I just have zipped it. Okay, and I have shared with you. So now if I open this that one, so see, this is actually your training notebook would be. just make sure you are saving that notebook, because whenever you are creating any kinds of different projects, at that time you can refer this notebook but change the data set. Okay, so you can use it as template. So first of all, what you need to do, make sure you have connected with your GPU. So that's why I will be changing my runtime with the GPU. So I have already the GPU. I'll be safe, and I will do the connect operation. So it will connect my collab. So yeah, it has been connected. Now, first of all, we need to install those dependencies. Suppose I need to first of all install this Yolo v5. Okay, so if I show you the Yolo v5 repo, so Yolo v5 GitHub. So if you just search, so here actually the first link Yolo v5, and it is from Ultra Analytics. Okay, Ultra Analytics is a, you can say, uh, there are organization. Okay, they have implemented this Yolo v5. So you can say it is from actually Darknet. Darknet is an organization. So they have actually made this Yolo v5. Okay, this is the implementation of Yolo v5, and this is the actually great repository. If you just go through the repository and if you just read in each and everything, their blog also, so you can understand actually each and everything. Okay, so now what I need to do, I need to just clone this repository. Okay, so for that, here actually you can see there is a link. So this is the link actually I have copied from here, copy, and I have pasted, and I'm doing the git clone operation. Okay, so now if I run that code, so now if I refresh, so here you can see Yolo v5 has been cloned here. Okay, all the files, whatever files you can see here, now those files are there. Okay, so now I have done cd operation. Cd means I want to enter it inside this Yolo v5 folder. So here you can see there is a Yolo v5 folder I have entered inside. Okay, so now here you can see there is a file called requirement.txt. Requirement.txt, if you open that file, so these are actually requirement you need to install. Okay, like matplotlib, numpy, opencv, pilo, okay, pytorch, you need to install. These are the thing. So this is the command for that. Pip install, this is the command, and it will automatically import your torch. Okay, and it will set up the version. So you don't have to worry, just run it as of now, because that will remain same for every project. Okay, you don't have to worry. A brief about Yolo v5. Yolo v5 is a, you can say, family of object detection architecture. Okay, suppose there are lots of object detection architecture available. Suppose faster RCNN, SSDNet. Then you have, you can say, RCNN. Okay, fast RCNN. These are some object detection model, but those model are actually heavy kinds of model. So what Yolo guys has done, they have come up with a new architecture, so called Yolo v5. Okay, so this is actually an algorithm, object detection algorithm, and this is actually state of the art algorithm. So if you see Yolo model, so there are 3 models are available. So if I show you their, you can say, model view. So let me show you. Where is the model view here? Yeah, so here is the model actually. If I click models, so see, these are the model are available. So Yolo, Yolo v5m, that means that is medium size model, that is nano size model, that is small size model, that is a large size model. Okay, so these are some model are available, but we will be using the small size model, Yolo v5s. Okay, so if you open that YAML file, so these are the actually architecture, like this backbone, and you can say this, all the, you can say, parameters they have defined. Okay, so as of now you can't understand what is that, but once you will learn the theory behind this Yolo v5, like how they have implemented this Yolo v5. If you open up the paper, okay, if you open up Yolo v5 paper, so you'll get the idea how they have like came up with the solution. But as of now we are not focusing on the theory part, just focus on the this practical part. Okay, just remember, like there are some models, okay, in Yolo v5, like large, small, medium, nano. Okay, so you can pick up any model, So you just have to mention those model name here. So it will automatically download that model and it will, you can say, doing the training for you. So here is the my notebook. So now what I have done, I have installed all the dependency. So let me show you. I think I have installed that. Let me run it again. Yeah. So setup completed. So you can see it's done. Now what I need to do, so this is the actually, here I am using, downloading my data set. So this is the link actually. If you copy that link and if you paste it, so you can see I have uploaded this data set inside my GitHub, okay, as a zip file. And if you have experience with Linux system, so you can see this curl is a, you can say, request command. Okay, we can use curl to download any kinds of file. Okay, so that's why I'm, because at the end this collab is a Linux system. Okay, that's why you can run Linux command here. So if you do curl operation, so here I'm saving this data set as zip file, then I'm doing unzipping it. So see, I'm unzipping it and I'm deleting my zip file here. So in one command I'm doing all the thing. So let me show you. So cd content, that means I want to come up with the content, and it's, see, it is downloading the data and it has unzipped it. So let me refresh. So see, you have your train images. Inside train you have images and you have your labels. Okay, and this is the data.yaml file. Okay, what are the things we have uploaded here, we have kept here. Or there is another way you can do. You can upload your data set inside this drive, and you can say, connect with your drive, like mount your drive, and you can define your path, like where is your data present, and you can do the unzip. Like if you do unzip operation, so it will unzip, or otherwise you can unzip the data and you can upload it and you can directly use that. Okay, it's up to you. But for easy to use, I have uploaded to my GitHub. Like this is the link. If I copy that link and if I paste it here and if I hit enter, so you see it will automatically start downloading. See, it is automatically start downloading. So that's how I've done. So now see, I have my data. So now if I do cat operation on my data.yaml, so now you can see my, it is reading all the file. Okay, that means your training path and validation path, number of class, and your class names. Okay, it is just printing. And now actually we need to change the config file. Okay, because there is a config file. So if I show you inside content Yolo v5, there is another folder called model, and there is a Yolo v5.yaml. Okay, see, so these are the config file actually. So these are the model I have already shown you. Okay, these are the model are available. But from here I will be using this Yolo v5s, that means small size model I will be using. So if I click on that, so here actually I need to change some of the parameters. Suppose if you see here, number of classes are 18. Okay, this is the number of classes presented at 18. Because why it is 18? Because this model actually trained on the Coco dataset. Okay, if you don't know, Coco is a dataset. Actually, it's a big dataset, and it has class around, you can say, around 80 classes. Okay, they have trained with 80 classes. That's why you can see 80 number of classes are 80. But for our case, how many classes we have? We have 6 classes, right? We have 6 classes. Yeah, Coco not only in TensorFlow, every like framework, every model, if you are like, suppose you are a researcher, you have come up with a new solution, new architecture, so you will be training that model with the Coco dataset first of all, because Coco is a, you can say, it's a benchmark data. Okay, that's why. So here actually we need to change those parameter, number of classes and your that thing. There is another thing called your depth multiple and width multiple. Okay, these are some default, but your main task could be to change this number of classes. Okay, 80. So I need to change it with the 6 because we have 6 number of classes. So I will close that. So this is the code for that. So if you just run it, And now if I print my number of classes, so from where it is reading, so it is reading my data.yml file. So see, I'm reading my data.yml file, and from that I'm picking up that thing like nc means number of classes. So see here, I'm retrieving that information, and this is my number of classes, 6. So now what I need to do, I need to go to that file, location. So Yolo v5 model, and this is the Yolo v5 s.yml. Okay, so this is the configuration file. So if I read it, so see, I have already shown you it has 80 classes. Now I need to change it. So for changing it, there is a code. This is the default code. If you want to change it, okay, in your Jupyter notebook itself, so you need to write, you can say write that line of code. Okay, so if I run it, and see, this is the right template, and you need to mention the path. Where is this file is presented? So this is the file. So you just copy path. Okay, copy path, and if I paste here, so see, this is the same path actually. This path and this path is same. Okay, I've just mentioned that path here, and now see, nc, that means number of classes, I'm mentioning with my number of classes. So where I have taken, so see, this is the number of classes I am replacing with, and now if I run that code, okay, so now if I run that code, and make sure you are defining with another name called custom, because that thing actually it has Yolo v5 s.yml, but I'm renaming with the custom Yolo v5 s.yml because I don't want to replace that file. I want to create a new file. Okay, that's why. But you can replace also, uh, but later on you will be lost that file. So that's why I have given the different name. Okay, so now if I run that file, so let me show you. So if I refresh that, so here you can see another folder file would be created, custom Yolo v5.s.yml. Okay, so this is the file, it has been created. So now if I open that file, so now see, our number of classes is 6. Okay, we have changed the number of classes. That was the main task here. First of all, it was 80 number of classes, but we have changed it with our custom number of classes, like with 6. Okay, so this is the code for that. So now your training would be started. Okay, this is the final code for training. So now let me show you. So I think till now, anyone, any question like how I have changed those, you can say a parameter like number of classes, and what is this YAML file all about? Anyone has any question? You can ask me. I already told you backbone and head, actually you will be knowing like when you will be learning about the theory behind this Yolo v5. Okay, these are actually some parameters. So actually whenever researcher has created this architecture, so they have defined some of the parameter. Okay, like backbone, and there are lots of parameter actually. So you don't have to change anything. You will be just sending those number of classes only. That's it. Yeah. So now this is the training code. So here is a file inside Yolo v5. See here, I'm doing cd operation inside Yolo v5 called train.py. Okay, there is a file called train.py. So you don't have to write anything. So they have written already for you. You will be just utilizing that. So here you'll be writing Python train.py. Here you need to define the image size. Okay, like I have mentioned 416, because that image size would be like that image size you are all giving. Okay, your raw image size you are giving. So let me show you collected images. So if I show you that properties details, so see, actually it is near to 480. Okay, so that's why I'm giving for I want to just, you can say, reside it 416. Okay, so that's why I have mentioned. But if you have higher resolution images, at that time you can increase that resolution size. But as of now, for these kinds of tasks, okay, 416 is fine, and batch size would be 16. If you have a better system, then you can increase that size. And I am considering number of epochs is equal to 10 because I want to show you quickly, so that's why. But if you are training it, so at least you train it around 300 epochs. Okay, just mention here 300. Okay, 300. So it will train around 300 epochs, but as of now I want to show you, that's why I will be training 10th number of epochs. And there is another parameter called data. Okay, underscore data. So here actually you need to pass this data.yaml file. So if I show you, so see, this is the data.yaml file you need to pass here. And this is the configuration. So that configuration we have generated. So inside Yolo v5 we have a model, and this is the custom Yolo v5 s.yaml. So this is the path you need to mention. Just copy the path, copy path, and mention here. Okay, this is the path, and this is the weights. Actually, weight means like your pretend model. So pretend model wise, what model we are using? We're using Yolo v5 s.pt, because I have already shown you the model here inside Yolo. So this is the model. These are the model are available. Okay, so here I'm using that model. So I will be just mentioning, I will just copy that model. Okay, I will just copy that spelling, and I'll be pasting here. So what it will do, it will automatically download that model. And here you need to mention this results name. Okay, results, because it will create another folder called Yolo results. Okay, and it will save all the, you can say, operation inside this Yolo v5 underscore results folder. So this is the basic operation. Now if I start my training, if I click on that, so it will start the training. So see, it is downloading the model. And if you do refresh here, so you can see there is another folder called run. It has been generated. Inside run, actually, it will save all the information. See, Yolo v5s results, this folder has created. And here it will be saving all the weights and all the, you can say, your accuracy metrics. Okay, all the thing it would be saved here. So here are two model you can see. One is last.pt, one is base.pt. So once our training is done, we'll be selecting this base.pt. Okay. So see, all the logs file is generating here, and your training is going on. This is your number of epochs, your GPU memory it is utilizing, and your mean average precision, how much you are getting. Okay, so what is mean average precision? One is what is this GPU memory you will be learning whenever you will be learning about this theory behind that. Okay, as of now, just consider it is giving some of the output. The high your MAP score is, like the best your model is performing. Just consider. And if you see the logging operation, it's good actually. Okay, you can see each and every information here. Okay, so our training is done, and now you can see, you can observe observe one thing. Actually, training is like very fast. See, I have trained 10 number of epochs, but it took actually less number of time. But if you are using TensorFlow, so at that time this training time is like very huge. Okay, so that's why we prefer this Yolo v5. And the installation was like very easy to install, and that training time was like also low. That's why every time whenever you are creating a solution, okay, just try to use Yolo v5 and detect on true, because these are some good model actually, state of the art model instead of TensorFlow. Okay, so I hope you got that. Like, as of now, anyone has any question? Epochs means, like, suppose how many how many iteration you want to do the training. That is the epochs. And steps means, like, steps can be like defined in multiple way. Suppose in optimizers we define steps, like after 5 steps we are reducing the learning rate. Okay, that's how we can define the steps. Okay, uh, uh, if you are taking very less size of images, so at that time it can affect. But make sure you are trying to take close. Okay, very close. Yeah, epochs means you can talk about the steps, like I have defined 10 number of epochs. What it will do, it will try to loop through 10 time. Okay, 10 time, and it will training your data, and it will calculate those metrics. Okay, and once it will calculate, and if it feel like, yeah, we haven't got good results, there is a huge loss, then it will again train. Okay, again train. That's how it will be increasing the epochs, number of epochs. In that data set, I have trained a model already with a 300 number of epochs. Okay, that was performing good, whatever I have shown as a demo in the video. So you can train around 300 epochs. But if you have, it depends upon your data number of data sets. Suppose I had taken around 120 images. Okay, so that's why I had considered 300 epochs. But if you have a, you can say large amount of data set, you can increase the epoch size like 1000, 2000. Okay, it's up to you. And if you have a good system, so it's fine. But I have already provided you the model. Okay, I will show you where I have given the model. So you can use my model. Okay, do the prediction. So as of now, I hope you got the idea like how to do the training. So this was the training code I have run, and it has trained my model, and it has saved those information inside that, like inside runs train YOLO v5s results, and all the like you can say logs it has been generated. And if you want to see your model, so this is the model actually base.pt. So now if you want to see the actually this evaluation metrics, so you can connect with your tensor board. So tensor board is nothing but it's a kind of UI based thing. So it will automatically pick those parameters, pick those actually matrices and the logs, and it will show you the kinds of, you can see UI. So you can see your model performance here. Let me show you kinds of graph it will give you. So see, this is the tensor board, and here you can see your actually your mean average precision. So as per your number of epochs is increasing, so it is also increasing, somewhere it is decreasing also, because it was picking up random images, so that's why. So this is the loss actually. As per your number of epochs is increasing, your loss is decreasing. Okay, so you can actually monitor your performance of the model, like training and validation thing here. So this is the code for which GPU you got actually. So I got Tesla K80. This is actually free collab I'm using, that's why. And if you want to plot those information actually, so you can plot it also. So you can see all the information in one place. This is the code. So see, this is my training box loss. This is my object loss. Okay, this is my class loss. All the metrics you can see here, and you can understand those metrics whenever you will be completing this theory part. Okay. So as of now, it's fine. Now I want to see my some of my demo. So let me print this my ground truth value. So these are my actually ground truth value. You can see hello, yes, thanks. Okay. And now I want to see my prediction. So this is the code file prediction. So, but here you can see here my level is 0, 1, 2, 3 like that. But I don't want. I want my level would be like as a text data. Okay, text. So for that, actually, you need to map those things. So let me run those things. Now this is the actually detect.py. Okay, you need to run. So it is presented inside. Let me show you YOLO v5. And here actually you have detect.py. Detect.py. See, detect.py. So you don't have to write the custom code for that. They have already written. So you have to just pass your trained model, like which model you got actually. So here, this is my detect.py. My weights, that means my best weight I got from here. So this is my trained model actually I got. So inside runs, train, results, weights, and base.py. Just copy that path and paste it here. Okay, so this is your weights. And here you need to mention the image size, whatever image size you took your training time. So just take it like 416, and your confidence score you can define. Confidence score as of now 0.1 is fine. Actually, it's an hyperparameter. You can take like how much confident you want, like your model would be predicting those images, and into test pass your test images path. So this is my test images path because I want to do the evaluation. So this is my test images path I am passing here. Now if I run that code, so it will do the prediction inside all the images. Okay, you have inside this test. See, it has already predicted and it has saved. It is telling it has saved detect experiment. So let me refresh. Let me click on YOLO v5, then runs, and there you will be getting detect and experiment 1, and here all the experiment you have. Okay, so see, it is not detecting anything because I have trained with a very less number of, you can say, epochs, around 10 number of epochs. That's why it is not able to detect. But if you are training around 300 epochs, okay, you will be getting a good, I mean, you can say prediction. So let me show you the prediction also. Uh, if you run that code, it won't be giving any result because I have trained with a less number of epochs. Okay, but in my you can say this uh, what I can say, like demo, I have already shown you it was detecting. Okay, it was detecting because I have trained with a high number of epochs, so that's why. Okay, so now your task would be like just collect your own images. Okay, and let me tell you one thing also. Suppose you want to save the model. Okay, for the future task, suppose you want to create a web application or anything, so you can save those model also. So for that you need to connect your Google Drive. So this is the code for that, like mount your Google Drive, connect with Google Drive. So I'm using that account, so I'll be selecting allow. So it is trying to connect with my Google Drive. So now if I refresh, so you can see my G drive here, and what are the files available inside my G drives, everything you can see here. So I'll be just you can say mounting to that path. Okay, so here I have already saved that model. So see, this is the code for that. Actually you have to define that path, like where you want to save your model. Okay, so this is the model I want to save, base.pt inside my weights, and I want to save it inside my detectron model. That means that folder. Okay, so this is the folder I have given, and if you click on that, so it will automatically save this model, okay, inside that file. Now you can download that model and you can do the inferencing. Okay, so how you can do the inferencing, I will be showing you. So this was all about the training and prediction process. Okay, make sure you have save this notebook as per your future you can say reference, so that if you are creating any kinds of new projects, so at that time you can use that. Just change your data with your custom data, and whole process would be same. Okay, and you make sure you are defining this YAML file. Inside YAML file you are defining your classes and your number of classes and your test directory and a train directory. Okay, so this was like all about this YOLO v5. And I think now you have got the idea like what is YOLO v5, and if you have any kinds of custom data, like how to train with the YOLO v5. What evaluation metrics, here you have this mean average precision and average precision. It's actually big theory. Okay, whenever you will be learning about the theory, so at that time you will get the idea of what is that. As of now, don't consider. As of now, by seeing the graph, actually you can observe your how your model is performing. See, that's why they have given the visualization now. So if you are not familiar with also, so you can observe like that many of after that many of epochs, like your model performance like that. Okay, so that is the thing. Now are you confident, are you can you create your custom, can you train your custom object detection model using YOLO v5 right now? See, you don't have to remember everything, just uh, refer that notebook, because I don't even remember all the comments. Line number 17. Okay, that is what you are talking about. So you don't have to change that. Actually, if you run that code like detect.py, so it will automatically actually you can say generate those text for you. So that's why they have written the code. So if you want to understand the code, you can open this detect.py and you can read their code, like how they are mapping those things. Okay, everything they have written. You can directly refer their code and you can create your web application. Even you can open up your camera real time. Detectron is another framework. It is from Facebook site. They have implemented using PyTorch. Okay, you can also use Detectron too for object detection and image segmentation, key point detection, all the thing. Yeah, what to do, I will show you. Like at the demo video I have shown you, I was opening my camera, right, and it was trying to detect my hand and all the thing, right? Have you seen? So I will be using that model like this base.pt, and I will be doing this inferencing with the video, like how I did, I will show you. Other framework you can't say, like see, actually it depends upon your task. Okay, but if you have you can say kinds of task, and if you want like faster inferencing, like faster you can say output, so at that time you can go with YOLO. And if you want like more optimized results, in medical science, what we know, like if any detection goes wrong, so what will happen, this patient might be die, right? So at that time we need more optimized results. So at that time we can, our inferencing might be, our prediction time might be, you can say, very high, but our accuracy would be like very you can say very high, right? So at that time we will be going with the TensorFlow or other you can say framework. But if we want kinds of you can say faster inferencing, at that time we will be using this Yolo 5 or detect on true. Okay, it depends upon your actually work responsibility. Once you have understanding all of the framework now, so you will realize like which framework you can see you will be using. Because I have seen like nobody uses this TF40, like because it is you can say hard to install also, like it takes time. So if you have a problem statement, people will be applying this YOLO v5 first of all. Okay, that thing, because YOLO 5 most of the time I have seen it will do your job and you will get a good result. And this code is also easy to understand, like everything is written in Python. Okay, I mean the PyTorch they have written, but now TF42 has come. Everything you can see with the Keras implementation. See, video video is, what is that? At the end, video is a frame, like frame by frame image is moving, and you can feel like it's a video is going on, right? So now you have trained with the images. Now you can use that model running on your video also. So at the backend, what will happen? It will take the frame and it will try to predict and it will show the output. That's how it will be doing like very fast, so that you can feel like, yeah, video is going on. I think you have seen from the demonstration video, right? No, segmentation cannot be done using YOLO. So for that, we'll be using the detect on true, because detect on true supports many kinds of segmentation tasks, like panoptic segmentation, instance segmentation, then your that one also, like semantic segmentation. Okay, three kinds of segmentation you have. Yeah, I'll be showing in the next lecture because it took lots of time to explain. Okay, and so that's why I'm taking, because detect on won't be taking much time to complete. Yeah, so I'll be showing you like how to run this base.pt. No, that's how you don't have to run. There is a code for that. So I hope you got the idea, like how to train a model, and these are the process. I think you are clear right now, right? And you have generated your model like base.pt file, right? So that is your actually trained model. Like you in your machine learning, you used to save using this pickle format, right? And used to use that for creating any kind of web application. Okay, now I have my base.pt model. Now what I will do, I will do the inferencing. As of now, I have done my training operation, but I haven't done the inferencing with my real images. Okay, with my real videos. So what I will do, so let me show you. So I think you have already cloned your repository, I'm assuming. Yeah, so if you have already cloned the repository, so here you'll be getting another folder called Yolo v5. Have you got? Yes. So if you just click on the Yolo v5, so here you can see base.pt model. Can you see this base.pt model? because I have given you my model, whatever model I have trained with a high number of epochs. Can you please check base.pt is there or not? Yeah. So now you can replace with your base.pt. Suppose what are the model you have saved here. Okay. Suppose you have trained with 1000 number of epochs and you have a good model. Okay. Better than me. What you can do, you can download that model. So you can download that model. After downloading, just do one thing. Just try to delete that model. Okay. And replace with your model. This Yolo v5 is nothing. I have just cloned their repo only. See, I have just cloned their repo only. Okay, and inside that detection.py, and I have deleted some of the file like contribution, contributing.md, and these are the file. Actually, I don't read, so that's why I have deleted, and I've kept all the file like same. Okay, what are the things inside detection2? I've just kept same. Sorry, Yolo v5, I've just kept same. Okay, because Yolo v5, why I like that, because they have implemented each and everything. I don't have to write, I can say, line of code for that for prediction. Okay, I can use their detect.py easily. Okay, and I can do my you can say inferencing. That's why. So now what you need to do, so if you open that run.py, so if I open my run.py here, let me open run.py. If you are using bash terminal, so you can directly run this run.py, so it will work. Otherwise, if you are using Conda, so at the time, just do one thing, just copy that command. Okay, this is the command, just copy python detect.py, weights is equal to base.pt, image size, confidence score, and source is equal to 0. Okay, just copy that. And once you have copied, now do one thing. Here actually I have okay. Okay. Now what I will do, I will just open my Anaconda prompt here. So let me open my Anaconda prompt. And inside, make sure you are creating your virtual environment and you're installing this requirement.txt. Okay. So just if you open that requirement.txt, so actually you need to install this requirement.txt. Okay. Just pip install hyphen. That's how like you install. Okay. You have to install this requirement.txt. So it will install all the requirements. Now you'd be able to run your, you can say YOLO this code. So for that, you need to activate your environment. So let me activate my environment. Let me do clear and Conda activate. Activate. Yeah. Okay, so it is telling I don't have any env. Let me see. Okay, I have in env here. So cd now Conda activate env. So I have activated my env. So what I will do, I will just go to my YOLO v5 folder cd. I'll write YOLO v5. So now I'm inside that folder. So now what I need to do, I need to copy that command. This is the command I need to copy. Okay, and I will open my terminal. Let me turn off my camera because it will open up my camera, and I will paste in here. Okay, so now if you just do a hit enter, so now it will see, it will open up your camera, and now if I do pause, so it will trying to predict me. Let's see. It is taking time because my system has been already slow. But if I close this zoom now, so it will work quickly. So I think everybody can see it is trying to predict hello. If I do like that, it will say yes, no, then I love you, then please. Hello. Okay. So now if you press Q, it should, okay. So what I will do, I will just press Ctrl C. So it will close my camera. Okay. So I hope you got the idea like how to do prediction with your camera. Yeah, some wrong is going on because my light condition is not good right now, because when I collected the images and when I trained my model at that time, I had a good light system, so that's why. So that's why actually you need to collect multiple images. I told you now. So uh, just try to collect with a different light condition. Okay, different actually angle, so that your model can learn a lot. Other method run, you can run this run.py if you are using bash terminal. Suppose I have git bash. Okay, if I show you, I have also git bash. I have also ubuntu. Okay, ubuntu like WSL also. So git bash, it will work. But if you don't have git bash, just try to open this run.py and try to copy that command. Okay, and try to using your command prompt and run it. Yeah, you can come up with your doubt clearing session, or we can ask talk about in our next class, because uh, it took a lots of time. Okay, so now I think you have the understanding. Okay, I will suggest you just to go through that lecture again, and do one thing, just try to execute by yourself. Okay, just try to collect your own images, try to train a model at least. Okay, and I will see, I want to see like how many of you can implement that projects like this sign language detection. I want to see you just upload it in your LinkedIn and mention me also. Okay, so that I can I am sharing my LinkedIn profile with you, so you can mention me, because that would be fun actually. If you see this project is actually, it's fun. Yeah, welcome, Vincent. So this is my profile, so you can connect with me here also. Just try to build that projects. Okay, try to do record and try to post it, also mention me. Okay, I'm sharing the OpenCV. Just wait. Yeah, because see, actually first time it will I know it will create issue, but just try to watch the recording. Okay, try to I mean execute yourself. If you are having problem, just try to connect with you guys also. Okay, suppose there is a guy, they can execute the code. That's why I told you now, if you are uploading to the LinkedIn, so if you are connected with them also, so you can ask like how did you done, like I'm having this issue, so can you please fix that. Okay, that's how you can actually make the actually community also. Okay, so people can get to know, okay, you are doing something. Okay, you are able to build something, right? Because going through the class is not the solution unless and until you are not doing anything. And people will start also following on your LinkedIn, so it will also impact on your job career also. Suppose if your manager sees your profile, okay, suppose you have a good follower, so they can understand, okay, you are doing something, so people, that's why are starting following you. Okay, so also try to build your online profile also, because online profile helps to get the job also. Okay, so someone needs OpenCV course, so let me see. There is a best video I can say. Okay, This guy actually explains in a good way, so you can follow that one. I'm sharing with you all. Actually, you can refer this OpenCV lecture. Yeah, Prashant, we are already connected. Okay. So I hope everything is fine with all of you. Uh, medical field, actually, it depends upon your what are kinds of solution you want to implement. So if you need a good accuracy, so at that time you will be going with a heavy model, okay, like resonate packet. You'd be using as a classifier, it would be using the resonate. Okay, whenever you will be learning about the theory, you will get the idea like which model to use and what are the things, because these are some lightweighted model, because the if you see, this architecture is also less number of parameter they're using. So inferencing power is very high, but accuracy wise, it will give you some actually less accuracy. Okay, so I'm sharing the GitHub link also. This is the Yolo GitHub link, and this is my GitHub link. You can follow on, so that you can follow lots of projects, okay, from my GitHub. So I think you got the idea. So how was the session, guys? Like, did you get the idea? Yeah, thanks everybody. Yeah, thank you. So thank you everyone, and thanks for joining the session. So if we get opportunity, so we'll be discussing about this detectron and this TF40 also. And it would be my suggestion, just try from your side, try to implement that one, okay, and try to upload it in your LinkedIn. So okay, thank you so much, guys. So I'm closing the session. So have a nice day. Thank you.